So for 21, we are subtracting fractions, so we need to have a common denominator. It's going to be easiest to see what that's going to be if these are already factored for us. So this right here is a PST, so it's just going to be x plus 3, x plus 3. So I have x over x plus 3 squared. And now to factor this, it's not going to group, so I'm going to have to do p's and q's right here. So my p is 9, so 1, 3, and 9. Q is just 1. So p over q is plus or minus 1, plus or minus 3, plus or minus 9. Set up my synthetic division. Again, I'm noticing as I write them that they're all positive, so I'm only going to try negative solutions here, and I'm going to try negative 3 first. Okay, so negative 3 works, and so that's one of my factors, and I also have this, and I can finish factoring this, x plus 3, x plus 1. I'm going to bring this down. That was, again, it was another factor of x plus 3. So you can see this denominator right here is actually going to be x plus 3 squared times x plus 1. So now that they're in factored form, it's pretty easy to see these are actually almost already common denominators. The only thing this fraction is missing is this x plus 1 over x plus 1. So I'm going to multiply this fraction by 1. This is a version of 1. X plus 1 over x plus 1 is just the number 1. So I can multiply that to the fraction without changing the value of the fraction. But now we can see that these have the same denominator. So this gives me x squared plus x over x plus 1, x plus 3 squared, minus 6 over x plus 3 squared, x plus 1. So these are the same. So now I'm going to combine them. I'm just going to slide over to the left here. I'm going to combine them over here. So I have x squared plus x minus 6 over x plus 3 squared, x plus 1. And then I'm going to factor this numerator and see if I can do anything with it. So x plus 3, x minus 2 over x plus 3 squared, x plus 1. So we can see that this cancels with one of these. So my final answer is x minus 2 over x plus 3, x plus 1. And if we want to go back and look for domain restrictions, we can see we have negative 3 from here, and then we have negative 3 and negative 1. And those are the same domains, those are the same denominators throughout the whole problem. So x is not allowed to equal negative 3 or negative 1.